All right, so today we're basically just going to focus on a couple linear regression examples. So a couple people emailed me with interesting ideas. One of them we won't get to today. I'm going to be doing some other examples in Excel in my other section tomorrow. So I'll post today's up on YouTube, but tomorrow I'll also be posting an additional YouTube videos, which will be different data sets of just linear regression examples. I think just hearing more interpretations, seeing more examples is helpful. So both of these will be up there tomorrow. Well, today's will be up there today, and you'll be watching today's for those of you who are here right now. But I put up a couple of files under that in-class data folder and linear regression. So the ones that we'll be looking at today are traffic data and then the shark attack data. Okay. So we'll start out with this shark attack data. It's kind of interesting. At least lets us start to think about intuitive relationships and kind of seeing the results play out in our regression analysis. We've got a bunch of different variables here. Some of them are qualitative, some of them are quantitative. Well, the issue is I can only use quantitative variables when I'm running a regression. So the very first thing I'm going to do is I'm just going to go to the last variable, Control Shift, hit the over and then the down arrow. So I'm just going to select my entire data set. I'm going to copy that and I'm going to paste it over here. This is kind of good, like best practices or whatever, in that we're not going to get rid of our raw data. So I'll kind of name this, here's our raw data. And we're going to mess with the data a little bit here, getting rid of some of the quantitative variables we can't use. And we'll call this our regression data. So, for right now, I'll just say I can't use these qualitative variables. So I'm going to just delete these. Get them out of the way here. Delete my qualitative variables there. I'm then going to be interested in a very, very basic kind of linear regression. So here, and just to kind of give you what these are measured in, I believe, and I try to go back, this might even be a unit that's more exact than millimeters, but for the sake of our interpretation, we'll assume that the way they measured this byte size was in millimeters. The length variable we kind of have is the length of the shark, and that's measured in feet. And actually, let me zoom in on this so we can see that a little better. So we've kind of got byte size in millimeters and the length in feet here. Right? We might also think that this byte size, I don't know, maybe it depends on kind of what the water temperature is or a myriad of different things. So the first thing we're going to look at is kind of just predicting. Oh, let me switch this over. To wait for a second here. I'll show you. I can kind of have the data pulled up and then, there we go. So maybe I'm thinking about, I want to try to predict what the byte size of the shark attack was. Right? And I'm thinking of that as a function of, I'm going to use water temperature to start out. Okay. So maybe, I don't know. Sharks get agitated more in colder water or vice versa. So maybe that's my naive kind of what I want to start out looking at. Okay. Switch this back here real quick. Bring class. There we go. So what I'm going to do is click on my data tab, go to data analysis. I should have this regression option, right? I'm going to select my Y variable. So my Y variable here was byte size. Kind of the easiest way to do this, hold Control Shift or Command Shift, and then hit the down arrow, all right, all at the same time. So that selects the entire variable. I'll then go click back on this arrow, sends me back to my regression kind of hub. The X variable that I want to include, after this first time, it should start sending me up to the top when I do this. I don't know why I did that. The second one I wanted to look at was water temperature. All right, so I'm going to then select Control Shift or Command Shift, hit the down arrow, selects that water temperature as my X variable. I selected the labels. I'm going to put it on a new worksheet. That's all I need to select. All right, so hit OK. And it spits this out over here. So I'm going to move this and call this regression, like Reg 1. Right? Let's zoom in. We'll start to think about some interpretation. Okay. So the very first thing we can look at is how much of the variation in our y variable are we explaining with the x variables we've included? Well, we only included one x variable at this point. The amount of variation, or the proportion of the variation we're explaining with the proportion of the variation in byte size we're explaining with water temperature is 0.000006. So we're explaining a very small amount of the variation in byte size with water temperatures. So in other words, we're probably not going to be able to make very good predictions, right? Because there's still basically 99.9999% that we haven't explained. Okay? So with that in mind, if I go back down here, we can still do interpretation on this coefficient, right? So the interpretation on this water temperature variable, well, the general interpretation is a 1 unit increase in x causes the predicted y value to increase or decrease by whatever that coefficient value is. Okay. So for us, a 1 unit change is going to be water temperature was 1 more degrees. And I can't remember if this was Celsius or Fahrenheit, but 1 more degree. So if the water is 1 degree, warmer, the predicted, if I can spell, predicted byte size increases. No, it doesn't. It's negative. So it decreases by about 7-8 millimeters. Right? So very, very small effect, but that's still how we would interpret it. Okay? So here's our interpretation. We look at the size as relatively small, and also if we look at the p-value here, well, we only reject the null if that p-value is less than alpha, right? That's the only time we reject. So if I'm looking at a p-value of 0.87, is that going to be less than 0.1? No. 0.05? No. 0.01? No. So I fail to reject the null. Now remember, in all these scenarios, we start out kind of assuming that these coefficients are equal to 0, that there's no relationship between our x and our y variables, making the alternative, right, that we're trying to test for whether or not there is a relationship, and then that slope coefficient is anything other than 0. Well, here we failed to reject the null, right? Our p-value was really large, 0.87, so we failed to reject the null. So we can't actually say there's any relationship between byte size and water temperatures. Right? That would be kind of the interpretation. It kind of makes sense because when we look at the r squared, it was so low, right? Like this one variable, we weren't able to capture like any of the variation in our y. So it's probably the case that, oh yeah, we can't really say that there's any relationship between water temperatures and the byte size based off the p-value that we got from this sample data. And it's probably pretty good evidence because I mean, we've got 3,600 observations here. It's not like we're dealing with a really small data set. Okay. So there's kind of our interpretation. We could then kind of move, well, first of all, before I keep going, any questions over anything I said there or just questions in general about regression as we're working through this? All right. So let's go back to that regression data and say, okay, well, look, I kind of ran a pretty naive regression there. If I look at these variables, which one do I think probably is a really good predictor of the byte size? My guess is, the time of the day, maybe, water temperature, water depth. The length of the shark seems like it'd probably be a really good, predictor. So what I'm going to do here is I'm going to include an additional control or an additional x variable. Right? So one issue we run into, Excel is great for kind of a tool to introduce regression, but it has its limitations that other statistical programs don't. So I'll show you one of them right now, and I'll show you how to deal with it. So let's say we've got byte size, that was our y variable. Then our x variable, we're going to select water temperature, but we're also going to select, and here I'm holding control, not water depth, sorry. Well, no, I don't want that here. Water temperature, hold control, and select length. Hold shift, the down arrow. Okay, I've got length and depth selected. Right? So go back up here. Got our label selected. There's a very loud error, and it says contiguous reference, right? So what's going wrong here? Well, Excel can only use multiple X variables if they're right next to each other. So that's kind of a pain, but it's not that big of a fix. I mean, I'm going to select this column, and I'm just going to move it over. So now that length and water temperature are right next to each other. So now I go back to data analysis. Got byte size already selected, so I don't have to mess with that. My X variables, I'm going to select length and water temperature now. They're right next to each other. Control Shift or Command Shift on a Mac and hit the down arrow. Selects the entire variable. Got my label selected, hit OK, and now it runs, no problem. So whenever you don't have variables right next to each other, you're just going to have to do a little bit of extra work, which is kind of move them so that they are next to each other. And that only applies to those X variables have to be next to each other. So I'm going to rename this and call this regression 2. Move it over here so we're doing things in order. Notice my R squared has risen to about 6%, right? Or the proportion of the variation in my Y variable byte size that I can explain is about 6, proportion is 0.06 or 6% using just these two X variables. Now notice water temperature is still, we can't say that there's any real relationship. That p-value is way too high. But if I look at the p-value on that length variable, it's basically 0, right? And e to the negative 53 means move the decimal 54 places to the left. Excuse me. So we can definitely reject the null here, which is that there's no relationship between the length of the shark and the byte size, and say that we found pretty strong evidence that there is, right? That slope coefficient is something other than 0. Now the interpretation would be a 1-unit increase in the X variable. So if a shark is 1 foot longer, then we would expect, then the predicted byte size would be, I have to minimize this, 155 millimeters larger. Right? Once again, I don't know exactly how they're measuring byte size here. I'm not a shark bite expert by any means, but however they're measuring this byte size, it would increase by 155 millimeters here. Okay? This might even be like surface area or something with byte size. So, and we can definitely say that this is statistically significant at all levels, right? A p-value of 0 is less than 0.1, less than 0.05, and less than 0.01. So we would say this is statistically significant at the 10%, 5%, and 1% levels, right? Because our p-value is less than 0.1, 0.05, and 0.01. And not only that, I forgot a part of my interpretation here. So the interpretation, when we have multiple variables, we still interpret it the same way, but we need to add something onto the end here, which is holding all else constant, which if we wanted to think about here, holding the water temperature constant. Okay. Any questions on anything here? I'll give you kind of a weird interpretation here as well. Well, I'll hold off. Let's do this. Let's do one more regression, and I'll give you an interpretation of the intercept. So maybe I look at some of these other variables and I say, I can at least control. Here's some other quantitative variables. So I've got age. Okay. Cancel. I didn't drag it over enough. So I've moved age over here. I'm going to move water depth. I thought I had one more variable that I could use. Oh, this is the hour of the day, kind of military time of when it occurred. So I'm going to move time over. So I've now got byte size, but I'm just going to include several more X variables here. So I go to my data analysis tab, regression, hit OK. My Y variable, I actually already have it selected because I've been using it, so it left it in there. My X variables, I'm going to include all of these. So Control Shift or Command Shift on a Mac and the down arrow, hit OK, I get my results. Now before I even go down to the bottom, if I look at my R squared here, we'll call this regression 3. My R squared, when I had water temperature and length, was 0.06359. when I included several other regressions, now the R-squared is 0.06394. So actually, 359. Oh yeah, 394. So it's went up a little bit, but hardly any at all. And that was from, including 3 additional variables. So what's probably true about those additional 3 variables? Well, if by including them in my regression, I can barely explain any more of the variation in my y variable, it probably means they weren't helping me make any better predictions. If they're not helping me make any better predictions, what's probably true is they don't have a real strong correlation with this y variable, right? For instance, think about when I threw in age into this y variable, or sorry, age as an x variable. Does it allow me to explain any more about byte size? And this is not the age of the shark, this is the age of the victim. Well, I don't know if if larger sharks like to bite older people or any smaller shark, maybe then I would pick some up, but I shouldn't expect this to really have much of a correlation with the bite size. And sure enough, when I look at that p-value, it's extremely high, right? 0.4. And when I look at the other variables I included, water depth, time of the day, this one's I'm a little surprised, but there's no difference, right? These p-values are all so high that I can't say that these coefficients, I can't reject the null. I fail to reject the null, which is that those coefficients would be equal to 0. Okay? And that's why, because they didn't, they're not significant, I wouldn't expect to see my R-squared go up by a whole lot as well. Okay? So here, I'll give you an interpretation of the intercept. So it gets a little bit goofy, but the intercept we always interpret as all the x variables are equal to 0. The intercept is the predicted value of the y variable. Right? So here, if we had the water temp was 0, length of the shark was 0, age of the victim was 0, et cetera, right? It happened at, I guess 0 would be here kind of like midnight to 1 a.m. probably. The water depth was 0. If all these are equal to 0, then the predicted byte size would be what? Negative 237.93. So this is a really good example and highlights the interpretation of the intercept can be really weird sometimes. How can I have a negative byte size? We can kind of give you a little bit of an idea. So if we were just to have 2 variables here, and let's say we were just thinking about what's a better one? We'll do kind of the length of the shark and then kind of the byte size. All right. Oops. To zoom out a little bit here. My guess is if we look at kind of shark attacks, like even if someone was bitten by a small shark, they're probably not reporting it if it's like a 1-foot shark, right? So probably most of our data is somewhere over here. As the shark gets longer, the byte size we would see probably is going up as well. The problem is when we draw this line of best fit, notice that intercept ends up being negative, right? It's below 0. Well, that's okay, because when we go to make predictions, we're never going to be putting in the age or the length of a shark that's anything smaller than, whatever this would end up being, 4 or 5. I don't know what the smallest value would be. But, we're never going to be putting in a value that's like in this range. So we're only ever going to be getting positive kind of bite-sized predictions, right? But that interpretation of the intercept, we still leave the same, right? Even if it's a scenario that we actually couldn't see in practice. Okay. Any questions on that before we keep moving? That's a little bit goofy, but that can occur. Okay. So the next thing is something I would not necessarily expect you to do, but I want to show you how you could do it. So let's say we go back to this data set, and remember, I was trying to just use my quantitative variables. There was also some qualitative variables as well. So one that I could use that might be kind of interesting is whether or not this attack was fatal. The problem is, it only comes in two ways. So notice when I have data and I have this filter on, if I click here, it shows me all the responses for that variable. So only an N and only a Y. So basically, I'm going to create this other variable, which is whether or not the attack was fatal. And I'm going to use this if statement. So, okay, look, if the observation value for this fatal YN variable, if that's equal to Y, comma, put a 1, comma, if that's false, just put a 0. So what that's going to do is it's going to look through this variable, and every time it sees a Y, that yes, this was fatal, it's going to put a 1. Every time it sees anything other than a Y, which here would be N for no, it puts a 0. So I've basically converted this qualitative variable into a quantitative variable, which is a 1 if the attack was fatal, 0 if not. So I did that for the first cell. When I click on that cell, notice how this goes to like this bold cross. So I double left click, it fills it in for my entire data set. Notice when I do finally have some Y's in here, I get some 1s. Okay. Now, what I'm about to show you, if you Google this or you know, talk to another stats person, they're going to tell you that what I'm doing isn't quite right, and that's true. But for the sake of this class, it's okay. We can use the results as though there's no issue with them. But anytime we have a 1-0 variable and we want to use that as our Y variable, we can do that. It's just Excel has some issues calculating that, which is okay for us. We'll just act like it doesn't. It's not that much of a bias that we need to worry too much. But I just do want you to be aware, if we do want to use a 1-0 variable as our Y variable, it's probably more appropriate to do so using another statistical program like SAS or SPSS or Stata. But we'll just act like the small bias doesn't exist. It's some behind the scenes computation issue that Excel has, but it doesn't make the results, it doesn't skew them too much. So what I'm going to do is I'm going to go to my data analysis tab. And what I'm going to be thinking about is I want to now look at not the byte size. I want to know if this is fatal. Right? So my Y variable I'll select is whether or not that shark attack was fatal. I'll then go to select my X variables. Right? So all I did there was, sorry if I did that too quick. After I selected my Y variable, I then went to select my X variable. So I'm going to include byte size all the way to time, all those variables that I had included before. I'm going to Control Shift or Command Shift on a Mac and select all of those. Hit OK. So move this over here. Call this reg fatal. Zoom in. First thing I'm going to look at here is our R squared. Now, of the variation that exists in this, was the attack fatal or not, is about 0.004. So just kind of to give an idea of what we're looking at here. We had, was this a fatal attack? And then we had all these other control variables on the right-hand side. Now, fatal was just a 0 or 1. So the interpretation of our coefficients now become a little bit different. Right? Before, it was, okay, if the length of the shark goes up by 1 foot, the byte size increases by this many millimeters. Right? We had a unit to our Y variable. Well, if our Y variable is just a 1 or a 0, our units are essentially like probability increases or decreases. Right? So our units here are going to be like changes in the probability. Now, we're not explaining a lot of the variation, right, that exists in this Y variable. So we got to take this with a grain of salt, right? There's probably a lot of other variables that we didn't include here that really matter, right? I'll talk about one of them here in a second after we get through a little bit more interpretation. So if I come down here now and I look at these results, well, first of all, which of these can I even say have a significant relationship with my Y variable, right? Which of them can I reject the null for? Byte size, that makes sense, right? The larger the byte, I'm guessing the more likely it is it's going to be a fatal attack. Water temperature, I can't say that has any relationship with whether or not it's a fatal attack. Length, this is kind of weird, but yeah, it doesn't matter if it's a 3-foot or a 13-foot shark if the byte size is the same. Remember, the interpretation now is if the shark was a 1 foot longer, holding everything else constant, so byte size was the same, water temperature was the same, right? Well, the byte size is really kind of probably what matters whether or not it's fatal, right? So we end up saying that the length of the shark really doesn't matter if we've got information on the byte size. Age isn't significant, water depth, none of these are significantly related to whether or not it was fatal, other than the byte size, which kind of makes sense. I mean, that seems like the most important factor, at least. Now, I'm a little surprised about the age variable here. That's not significant, but I'll go over this in just a second. So I'll do one more interpretation for you. If we go to the length, or the byte size variable, I'll just minimize this for now, maybe. There we go. So if we look at the range, it goes from 0 all the way up into like the thousands, right? So when I'm interpreting this, yeah, this is the impact of being 1 more millimeter, like the byte size increasing by 1 millimeter, right? Well, if the range is like 0 into the thousands, it's probably possible I could think about, well, what if the byte size was 1,000 millimeters larger, right? So if it was 1,000 millimeters larger, but I have the effect of 1 unit, just multiply that by 1,000, and now I get some more practical kind of interpretations, right? If the byte size goes up by 1,000 millimeters, the probability that it becomes a fatal attack goes up by, what, 1.7%, or the probability increase of 0.017. Okay. We kind of already did the interpretation there. So, you know, making it a little bit more practical to think about, well, what if it wasn't just a 1 unit change, if my units are really small? Well, what if it was a more practical increase, like a 1,000 millimeter increase in byte size? Any questions on any of this before I kind of continue here? Okay. So one thing I did want to point out here and harp on a little bit, because I see this even in, at my level, is if I'm looking at this p-value, it's 0.12, right? So if I think about what levels could I reject at, like what levels could I reject that null hypothesis at? Well, I only reject if the p-value, right, is less than alpha. So if I think about alphas of 0.1, 0.05, and 0.01, right, this p-value of 0.128, it's not going to be less than any of them, right? So basically, if it's not less than alpha, I fail to reject. I'm not going to worry about wasting time doing if statements here. We can see it with our, I think, pretty easily. So what I'm failing to reject is that relationship, right, between now, I guess I should get rid of this byte size here. All right, so I started out always assuming that coefficient is equal to 0. So I'm failing to reject this. So I'm saying, okay, there's no relationship between whether or not it's a fatal attack and age, all right? Now, the issue is, though, this is really close. I mean, pretty close to being able to reject at the 10% significance level, which is kind of similar to like rejecting with 90% confidence, right? So just because I can't reject at the 10% significance level, I could think about here, well, what if alpha was 0.13? Well, I actually could reject at the 13%. Well, how different is 10 and 13%? You know, I mean, we're kind of splitting hairs here. Yeah, I have to set my threshold or my benchmark somewhere, but even though we can't reject the null at the 10% level, it's pretty close here. So we don't just want to throw away this evidence. This is still pretty strong evidence that there's a relationship between age and whether or not the attack was fatal, which I think intuitively makes sense, right? If someone's older, the same size, you know, think about it this way, it's a byte size of the same size, same water temperature, same length of the shark, same water depth, same time of the day, but one person is 1 year older, we see an increase in the likelihood that it's a fatal attack, which I think intuitively makes sense. And yeah, it's not significant at our benchmark 10% level, but it's really close, right? That p-value, we shouldn't just be ignoring this evidence. Okay. Now that's in practicality. If you're asked about rejection decisions on the exam, you still have to say that you failed to reject here, right? Any other questions on this before? I think we'll move to another data set here. Okay with this? All right, and I'll post kind of some of the work that we did here on Canvas when we're done. So the other one I want to go to is this traffic data. So I've got a bunch of different information on these traffic stops. So I had a much larger data set, but one thing I'll show you that's really kind of nice to do. So I'm going to just go to the first variable, Control Shift, Command Shift Automatic, hit over and then down, selected my entire data set. I'm just going to go to filter it. Like that's just kind of a best practice. Always throw a filter on there. There's no reason not to. I've got information on things like what is the gender of the officer, race of the officer. Now some of these came in, like it didn't tell me what the race was, so I had to kind of use I had a Word document that told me, a 3 means, white, and 5 is just black, 4 is Hispanic, or whatever it was, right? So I then created some of these other variables over here, which is going to be primarily the ones that we're using. Okay. Well, I go over. One thing I also did, just to kind of set this up, is notice the reason the stop is a 7 here. I got rid of all the data where the reason of the stop wasn't just a common traffic violation, right? Like if the reason of the stop was suspected gun or something like that, well, I want to be comparing apples to apples. We don't really have quite enough to start thinking about multiple indicator variables. So I made sure we're just looking at common traffic stops here. And this is a data set that comes from Houston, Texas. Well, I don't know that for sure. It's a large metropolitan city in southeast Texas, which I'm guessing is Houston. So we'll look at some of this information. We'll go all the way over. And what I'm going to try to do, and this is where kind of similar to whether or not it was fatal, we're going to look at what if we have a 1-0 y variable and start thinking about making interpretations when it reflects probability increases or decreases. So I want to look at whether or not someone gets a ticket. And the first things that I'm going to do is I'm going to say, okay, I want to try to predict this using the driver's age, and I've got kind of the officer's years of service, right? So I'm just going to start out with that regression to kind of set this up. So we'll go over here, data analysis, regression, select my y variable, which is whether or not they got a ticket. Okay, so I'll select that, x variables, driver's age, and officer's years of service, which I conveniently ahead of class moved right next to each other, so we can just select those two as well. Got my label selected. I'll put it on a new worksheet. I'm going to rename this Reg 1. I'm going to zoom in so we can actually see what's going on here. Now, first of all, the percent, or the proportion, I should say, of the variation that we can explain is about 0.01 in whether or not someone is given a ticket when they're pulled over. So only about 1% of the variation. So we should take this with a grain of salt, be cautious about these results, but still, right, we can interpret them. So we'll scroll down here. Now, first of all, if we look at these p-values, at any level, I should be easily, right, rejecting that null. Because those p-values, e to the -7 and e to the -57, those are basically 0, right? So that's going to, my p-values are easily less than any alpha that I want to look at. So I'm rejecting that there's no relationship, or said differently, I'm saying there is a significant relationship between age and whether or not someone gets a ticket, and officer's years of service and whether or not someone gets a ticket. So if I think about the interpretation here, well, both of my x variables are in years, right? So here it would be, if the driver is 1 year older, the predicted decrease in the probability they get a ticket is 0.00 about 4, right, or 0.0038. Holding constant the officer's years of service, right? And if I wanted to interpret officer's years of service, holding constant the driver's age, if the officer is 1 year older, right, or sorry, I shouldn't say 1 year older, has 1 more year of experience on the force, the probability they issue a ticket goes up by about 0.002. So, I guess what this is telling us is, these kind of make sense. I mean, I guess as someone gets older, they're less likely to get a ticket once they're pulled over. I can speak for myself. My interactions with a police officer at the age of 16 are probably very different than they would be now if I got pulled over. Probably making it so that now I'm less likely to get a ticket for doing the exact same thing. Right? Not saying I was the most arrogant person in the world, but I don't think that I probably would have come across a little bit differently then as I would today. So the other one that's intuitive, right? This officer years of service, is an officer has more years of experience in the force and they pull you over, they're more likely to issue a ticket. This could be because they're probably not as likely to pull you over for things they know are going to not lead to a ticket, right? So this is, kind of makes sense. So I guess next time you get pulled over, you don't want to see, you want to see a really young officer here. So your chances of getting a ticket would be less likely, right, if they're younger. So that's kind of interesting, sets us up for thinking about what we're going to do next, okay? So I'm going to go back to that regression data. And I've got these other things that I created, which are, I think, pretty interesting. So we can start to look at things like the driver's gender, the officer's race, the driver's race. And then I did this combination, right? So this is a little bit outside the scope of this class, but for the sake of today, I think we can at least understand it, which is, what if the officer is white and the driver is non-white? Okay. So this is only a 1 if the officer is white and the driver is non-white, 0 in every other situation, right? So this is going to help us start to identify, is there maybe some discrimination going on from white officers towards non-white drivers, right? You can imagine a much, more detailed study or a better analysis of this would be like we could break down race into every category. We could look at different combinations, but just for the sake of showing you how you could identify discrimination, we're just going to look at this officer being white and the drivers being non-white. Hopefully we don't see any relationship between this and whether or not someone gets a ticket. Because if this is statistically significant, that's evidence that we have discrimination going on. Right? So I'm going to include quite a few additional X variables here. So we're going to go up to data analysis, regression. Now it's kind of nice. I'm still looking at whether or not the person got a ticket, but my X variables, I'm going to start with the driver being male all the way over to the officer's years of service, right? So quite a few control variables here. Control shift or command shift down, select all of them, got my labels, put it on a new worksheet, call this Reg 2, zoom in. Now notice when we're looking at whether or not someone gets a ticket, and we've included all these other X variables. Before, we were only explaining 0.01, right? Our proportion of the variation in that ticket variable. Now we're explaining about 0.03, the proportion we're explaining of the variation that exists in that ticket variable. So we increased by quite a bit. So some of these variables look like they matter. So we go down here. We've got our old driver's age and officer's years of service. They still have the kind of same sign, still very significant, right? P-value is pretty much 0. Now, we can kind of start to interpret just these indicator variables. I don't know exactly what's going on, why kind of just being a white officer means you're less likely to kind of issue a ticket. We would probably need a lot more control variables to really get a good understanding of all of this. But if we look at that, is the officer white and is the driver non-white? And we say, okay, a 1 unit increase in this would be any other stop where the officer is not, where the combination of officer and driver race is not officer being white and driver being non-white, right? So compared to that scenario, going from there to officer being white and the driver being non-white, right? That's how this variable becomes a 1. The expected or the predicted change in whether or not someone gets issued a ticket, the probability goes up by about 0.06. So if the officer is white and the driver is non-white, holding everything else constant, right? Holding constant whether or not they're both male, driver's age, years of service. In that type of a traffic stop, the probability a ticket is issued is about 6% higher, or the probability goes up by about 0.06. So this is bad, right? This is evidence that there's discrimination going on in the issuing of tickets. And if I look at that p-value, it's pretty much 0. Right? So this is, this should be concerning, right? Yeah, this definitely should be concerning, right? Let me think if there's anything else I want to mention here. You can kind of notice it looks like maybe the driver being male, at least if we're looking at kind of gender different, like is there discrimination going on, or male drivers being given tickets more or less than female? P-value is pretty high there. We can't really say that gender matters, but it looks like the combination of kind of and even if we look at the driver being white, right? That's not a significant effect. It's really only when you have kind of this cross race thing going on, where the officer is white and the driver is non-white. That's where the change occurs in the probability of getting a ticket at a statistically significant level. Okay. So this kind of shows the power of what we can do with these regressions. We've found some evidence of discrimination. Right? Now, to be fair, like, remember, this is just a correlation. If we had, more information about where the stop occurred, maybe previous, arrest or driving violations, or more information on the officers, even in the data set, I didn't include everything, right? Like, I go to the top. I think I had, if the officer was male or female, I could control for that. Whether, I guess these don't quite apply, but, I probably, for a more accurate regression, would need more information than I have. But this is still, given the limitations that I have with my data, evidence that maybe there's some discrimination going on. Now, when I was setting this example up for class, I was like, oh, this is bad news. I feel like I need to try to see if there's something that can kind of soften this blow for looking at this data. So I'll go back, and I'm going to include the exact same X variables, but instead of whether or not a ticket was issued, I'm actually going to look at whether or not an arrest occurred. Okay? So I'm going to highlight that arrest variable. Got my label selected, hit OK. Call this regression 3. So when we're going back and looking at this, you can kind of line things up. Now when I zoom in on these results, we'll notice the R squared is very low. So I'm not able to explain a lot of the variation that exists in whether or not someone's arrested, which kind of makes sense. There's a lot of other factors other than race, gender, age that matter, right? But I can still interpret kind of the results I see. And when I go down here, if I look at that same variable, right, whether or not the officer is white and the driver is non-white, that combination occurring. Now when we see that type of a traffic stop relative to any other combination of officer and driver races, right, the increase in the probability that they get arrested goes up by 0.002. So it's a much smaller impact. And also, the p-value is 0.39. I actually can't say that there's any difference in the probability that an arrest occurs in a traffic stop if the officer is white and the driver is non-white. I can't say that there's any significant relationship between this scenario and whether or not an arrest occurred, because I start out assuming that relationship is equal to 0 with a p-value of 0.39. I failed to reject this. So even though we found some evidence that discrimination occurred in the issuing of tickets to kind of when the officer was white and the driver is non-white, at least the probability that they get arrested doesn't look like it's any different, right, from any other type of scenario. So some evidence of discrimination, at least it's not kind of at the most extreme levels of being arrested. Now, like I said, this isn't a perfect analysis. There's a lot of control variables that we probably would want to put on the right-hand side. I mean, there's still, 99.6% of the variation left unexplained. So we're missing some really important stuff here. But this is, I think highlights the power of what we can do with regression, gives us just some more interpretation of these, binary variables, just different looks, thinking about which of these variables can we reject the null at, and hopefully bolstering our understanding of kind of linear regression here. Excuse me. Any other questions on anything before we kind of keep going here? Got a little bit more I want to say before we get out of here. Okay. I think that's all I kind of want to do with regression. Like I said, I will be doing, let's get here. So I'll be doing some other examples. Ooh, this is kind of trippy. I'll be doing some other examples in my section tomorrow. I think I'll probably got some more requests for some sports stuff. So they'll probably have I think a basketball example in there. And I'll include another data set as well. So I'll post that tomorrow. You'll just have more examples of linear regression. I have the exam written. It's about 15 multiple choice, 2 short answers that have multiple parts to them. I'll go in a little more detail on Wednesday and Friday about that, but the exam will be open from Monday to Wednesday, tentatively. That's kind of my plan. We will still do review Wednesday, Friday, and Monday. So I would suggest, even though it's open all day Monday, I'm not really expecting anyone to kind of work on it until after, probably Monday evening or night, and then Tuesday and Wednesday. Similar to last exams, once you start, you'll have 2 hours this time, so timing shouldn't be near as much of an issue on this. Very similar format. We'll start working through the practice exams, and I'll be pointing out some more helpful tips and hints on how to and what to maybe study over the next couple classes. So we're done with online quizzes for this semester since we're just doing review from here on out. I will at some point, I don't know if it'll happen today or tomorrow, get it so that we'll get your grade up on Canvas that reflects dropping the 3 lowest iClickers, because that was, or iClickers, online quizzes, because that's kind of in the syllabus. So it's what I'll do at the end of the semester. So that should help kind of give you a little bit more accurate idea of where your grade's at. I'll also do the same thing for the Learn Smart, since we're not going to have any more of those. As I get the Connect and Excels graded as they come in over the next week, I'll also do a similar thing for the Connect and Excel, showing you on Canvas what your grade is with that lowest dropped. Okay? Any other questions from me before we get out of here? All right, I should cover. So I'll see you guys on Wednesday.